Let me start now for my session about working with time series data in Azure. I had a very short call with Magnus Ahlqvist last week on his SQL Friday, where I already presented some of the stuff I'm going to show today, where I discussed some of the stuff I'm going to show today. But today, of course, being at SQL Bits, for me, this is the first time at SQL Bits, and it's awesome. Having the chance to present it live, I'll present much more than I showed in that brief online session. So I'm going to talk a bit about how you can work with time series data in Microsoft Azure. And when I did this last week online, I opened because I know that, like me, Magnus is a music fan and likes metal music. I opened with a quote from Blind Guardian's "Time, What is Time?" But somehow coming to London and quoting a German metal band felt wrong. So I decided to open with a different quote here about people assuming that time is a strict progression from cause to effect, but it actually, from a non-linear, non-subjective viewpoint, it's more like a big ball of wobbly, timey-wimey stuff. So I think that captures the essence of what I'm going to talk about very well. And so from a scientific standpoint, this is basically what we'll be talking about, this ball of timey-wimey stuff. This is, of course, a quote from the 10th Doctor, Doctor Who. Coming to England, I felt like talking about time, it has to be Doctor Who who's mentioned. And coming to England and mentioning Doctor Who, I also felt like I had to bring Doctor Who, and I had to bring Doctor Who in an arcade style. So I did what all people who lack the talent do. I went to Fiverr and had somebody create Doctor Who for me. So here's Doctor Who for you, just to open this session. Now, we've talked about this wobbly, timey-wimey stuff. Let's get this a bit more narrowed down and a bit more specific, because it's easier if we have a bit more specific information. I know, being a consultant, customer requirements often feel like this wobbly, timey-wimey stuff, but I like to narrow it down a little bit more to know what we're actually talking about, and I feel like this might help you too if we manage to narrow it down a little bit. Before I continue, if there's anything that is unclear during this presentation, if you have any remarks or comments, feel free to interrupt me at any time, to ask questions, to discuss, to remark, and I'll be happy to sidetrack into discussions whenever anyone has anything they'd like to comment on. I'm not seeing too well into all of the corners of the room, but make yourself noticed. Also, the online people, the lovely people in orange, are monitoring the chat and will notify me if there's anything going on, so please tell me if there's anything. So, time series data. What is time series data? Okay, first, let's take the wibbly-wobbly part out of time and have it as line, like we often do when we have representations of physical data or stuff. So this is our time, and now this red dot here is a measurement at a point in time. And then there's another one, and several others. And what we have here is a series of data associated with certain timestamps, so time series data. Easy enough, right? Now, this could also look a bit different. We could have this blue dot here, and then this one, and then maybe for some time no measurements, and then that, and randomly distributed measurements. Now that's the first bit where people start discussing, and this is actual discussions going on in certain communities, whether data that appears at random points in time is still time series data. I'll shortcut this discussion here and say yes, it is. In this session, the blue dots are time series data as well as the red dots. Okay? I hope everyone can live with that. Okay, so if we try to make that a real definition, and I'll come to why I love definitions so much later. The real definition is we have a timestamp associated with data, or data associated with timestamp, depending on which way you would like to see it. Values are measured or occurring at regular or irregular times, so they might occur whenever. And now comes the interesting part. Time series data, in our definition, is append only, meaning we progress through time, and at this time, a new data point arrives, at this time a new data point arrives, and it doesn't go back. So as time progresses on, so does our time series data. Of course, this is an approximation because we know that we have things like lag in internet connections, offline scenarios where data might not arrive in the right order. But speaking of the time series, it's append only. A new data point arrives at a new time, and it's added to my data set. And unless we have a device that allows us to move back and forth throughout that timeline, such like this, we'll have to live with the fact that time series data is append only. I don't have a TARDIS, unfortunately, so for me, time series data is append only. We can only add new data to the end of the time series as it occurs. As I said, this is to be taken with a grain of salt, as we all know that there's things like lag and irregular connection speeds and data arriving at irregular times. So you might be off. So you might be off with receiving that data, but it still occurs in an append-only manner. Okay, and now you've all decided to choose to come to a session about time series data today. So the next slide kind of sometimes feels a bit obsolete, but I still like to show it. Why is it important? You all know why it's important, otherwise you probably wouldn't be here, but you would be at one of the other great sessions. Why is it important? We have lots of data like IoT data, where you measure certain physical values progressing over time. We have things like monitoring and logging of services, cloud services, on-premise services. And this is actually also the example why I have chosen to accept non-regular time intervals as time series data, because logging in my application occurs whenever anything happens on the application, and that's not at predefined times usually. If I have users on an application, the logs will occur whenever the user uses the application, and that might be irregular intervals. So if I want to include logging data and consider logging data when working with time series, then I'll have to allow for irregular intervals. And also things like financial transactions are usually time series, where you see, okay, my stock has a certain value, and then time marches on and the value is written on. So those are examples why time series data might be important. And I thought, as we start with all this, and I've started to give some definitions and everything, maybe this is a good point to define why I am standing here and talking about this. Because, well, anyone can talk about anything, and I wanted to motivate why this is a topic that I'm working on and that I'm usually occupied with. So, what am I? Well, first of all, I'm a father. I'm a music nerd, but that doesn't contribute to my time series, only as the time progresses and my record collection grows. That's the only time series associated with my music. I'm a Microsoft MVP, and I'm fond of definitions because I'm a mathematician, though I'm usually well behaved, but so I won't be showing any formulas or integrals or stuff. So you can rest assured, this has been trained out of me over the last few years. And why do I work with time series data? Why is time series data important for me? 6 years ago, I founded a company, MLPA, and we do end-to-end delivery of IoT projects. So we're guilty of creating a lot of these time series data that I talked about. So we build devices for customers that capture data and then send it to the cloud. So time series data is actually something that in our projects with our customers I work with on a daily basis. Now, time series data is kind of special. And so the question is, in which way is time series data special, other than that it's append only? And why should we need specialized databases, specialized engines to work with time series data? And I'm trying to answer some of those, give some of those arguments now. So due to the shape of time series data, usually your time series data has a timestamp and a physical value it measured. Sometimes 2 or 3 or 4, but a limited set. And usually, this can be compressed very well because the shape of the data is very clear. And that goes for basically all time series data, more or less, that we spoke about in the examples before. So we can usually compress time series data at a rather high level if we choose the right compression, the right algorithms to store and retrieve that data. Furthermore, when we work with time series data, we tend to ask very similar questions over and over again. So questions will be, what was the value of this measurable at a certain point in time? Or what was the average value of this, of the room temperature throughout the day? So we ask things like, we want to retrieve a single interval. We want to retrieve the latest data point measured, or we want to retrieve intervals. So usually what we do, we'll have some kind of query where we either filter for single or intervals of those time values that are associated with our data, and then we might aggregate or not. But that's basically most of the operations you'll do with time series data. It's very unlikely that you'll ask a question to a time series database like, just imagine you had a sensor here measuring the room temperature. It's very unlikely that you would say, give me the average room temperature without saying from today. Because the time adds value to the information. So this is the typical operation that you'll ask. This is the typical query that you'll write. And so it makes sense to have your database prepared for that kind of question and have things in place to deal with that kind of question that you'll ask to your data. And if we think of that, basically, I'm assuming, quick show of hands, who works with SQL Server, SQL databases? Perfect. So I'm assuming that if I gave you a table with time series data and the queries associated with that, most of you would know how to index that. And we'll be able to index that so that we can do single value retrievals, interval retrievals at really good speeds. And that's great. So why do we need a specialized database? Why is a specialized database even a thing? And it is basically a level of comfort. It just takes some stuff off you that is done by the vendor because they know that this is going to happen. So basically, of course, you can build everything yourself from scratch and create your own time series database, but you can use a database that the vendor has prepared in a way that it accommodates those kind of queries and that kind of data. And what I want to do now is discuss various options for storing time series data in the cloud in Azure. So let's start by that. And due to the show of hands, I know that everybody will have thought of Azure SQL Database, Managed Instance, or SQL Server in a VM, or any solution like that. And of course, this has some really nice features to it. I mean, it's a well-known tech stack. All of you know that tech stack. We all know how we can connect the connectivities well. We have things like Entity Framework that we can use if we want to develop an application against that database. We have management tools for all of that. So it's a really good tech stack to work on, and it's a really comfortable tech stack to work on. Downside is, off the shelf, it's not optimized for timescale data. So it will require you, if you have large amounts of time series data in there, it will require you to do some index tuning, to do some work to get that really down. And what's more than that, I was now just focusing on getting data out of the database, but also getting data into the database can be an issue. So we're talking about things like, if we're talking SQL Server, in-memory OLTP tables that we might need for that. And then some mechanism for for persisting the data in historical data tables and stuff. So there's many things that we might need to consider depending on the load on the database. And so often in my projects, customers come up with alternative technologies that they would like to discuss and would like to know about. One of the most frequently mentioned tech stacks for working with time series data is actually Postgres database together with the timescale extension. Now, we just saw who worked with SQL Server. Who's worked with Postgres before? Okay, not quite so many. Great thing about Postgres is that you can have it as a platform as service on Azure, so you don't need to create a virtual machine and manage a virtual machine, even a Linux virtual machine or anything, but all that is done for you, so you can have this as a platform service. And the timescale extension is an extension that you can just enable for Postgres database. And what that is, it's basically, just as I mentioned before, it's just those comfort features that that it gives you indexes and store procedures and stuff for ingesting time series data as it comes in an efficient way, and for querying it in an efficient way. And what an efficient way means, I'll show later. So the upside is the tech stack is still quite elaborate. You can connect to it from Azure Data Studio. You can use Entity Framework with Postgres databases. It's available as a platform service, and it's optimized if you use the timescale extension for working with time series data. Downside in my experiences, I never managed to get connection pooling working the way I expect connection pooling to work with Postgres on Azure. Might be my fault, but somehow this seems to be a bit tricky. And the second downside is the timescale extension, if anyone's ever seen that, is very, very specific when it comes to naming. For example, Postgres is case sensitive in table names, which is okay if you know it. The timescale extension doesn't allow for uppercase letters, which is a bit of a bummer if you've designed your database and then want to turn on the timescale extension, and will just fail telling you this table does not exist. And you say, well, I can see it's here. Why are you telling me it doesn't exist? And the timescale extension will just say it doesn't exist and go on. And then you Google for half a day, and then you find that, and you rename your table to be lowercase and snake case and whatever. And then the timescale extension will go, yeah, the table exists, but that column doesn't exist. This cost me 2 days till I figured out no uppercase letters anywhere near the timescale extension. So if you ever try to set that up, keep that in mind and be thankful that I just saved you at least a day of work trying to figure that out yourself, because the error messages are very, very unspecific, and it's really, really annoying. Okay. But there are also other options. Another option that I use quite often is I get time series data. Basically what I get is JSON messages sent from an IoT device. What do I do with them? Well, first thing I do is I dump them in a storage account, blob storage. Yeah, hell, it's cheap. It costs next to nothing. Great thing. So, good solution to store your data. Yeah. Easy to handle. I mean, setting up a storage account is, I don't know, few lines of bicep code. And if you want to know how many lines of bicep code it actually is, you need to go to Frank Geisler and Timur's session later on, because they will be talking about bicep templates. So it's very easy to handle, very easy to set up. Downside is it's not optimized for querying at all. So you can dump everything in there. And if you want to retrieve data from your storage account, you should have a reasonable storage strategy at hand. For example, what I used to do is IoT Hub or even Stream Analytics have outputs that go to the storage account. And think, hey, this is great. I can just let IoT Hub dump all the data in the storage account. Perfect. Job done. What happens is IoT Hub will create folders for month, year, day, and then create files for the hour, and just dump data from all devices in the same file. Now, usually what you want to do is you want to say, what was the room temperature in this room? Meaning for this device that's located in this room throughout the day. So you'll have some filter that filters for a device. And if you want to do that with the standard storage, you'll have to open each file that is placed in the storage account and read all the lines to find the lines that correspond to that device. So you'll need to implement something yourself that orders the data in the way that you'll want to work with it later on. This is important. I learned that the hard way. I had to reformat, repartition, reorganize terabytes of data, and it's not a fun thing to do. So keep that in mind. Storage accounts, easy, cheap, great solution. When it comes to querying, if you've been to the keynote, you've seen how easy it is to use external tables from Synapse serverless pool or from a SQL database to get data off a storage account. So that's really, even methods of querying are there and work reasonably well. I use them a lot in projects with my customers, but it's comparably slow. Let's move a bit on. ADX. ADX is, I don't know, sometimes it feels like many people don't appreciate what ADX really does. It's made for querying time series data. It's made for querying vast amounts of time series data because it's made for working with log files. So it's really a great solution if you want to query, if you want to work with your time series data and want to retrieve it really fast. Downside is that you'll have, well, this could also be an upside. You get to work with Kusto. You'll have to work with Kusto, depending. If you're SQL folks, maybe it feels more like a downside to have to work with Kusto. And that means there is no, the support, the landscape of tooling that you can use with that is more limited than with the two relational options that we've seen so far. And now in the end, I'll just go a bit quickly because I'm still in the time frame, but I'd like to show some more stuff later on. There's specialized databases that are made for working with time series data. Most popular one that you'll find out there, my feeling from the size of the community and the number of posts you find on Stack Overflow and other communities, is InfluxDB, which is a dedicated tech stack for working with time series data. So again, similar to the timescale extension in Postgres, this is made for working with time series data. Downside is this is not a managed service in Azure. So you'll have to run your own virtual machine, usually more than one, and you'll have to maintain them, and you'll have to run updates on them, and you'll have to take care which version your database is at. This is a lot of effort, a lot of maintenance effort that you'll have to invest if you want to leverage this technology stack. And basically the same goes for OpenTSDB, which is also a very popular open source time series database. So those are some of the options. I'm pretty sure every one of you can think of at least two more that should be in this list and that I'm missing. But those are some of the options that you have for work. That's the problem with the cloud, right? If you mention two services, you're missing at least two. So I've mentioned 6, I'm missing at least 6. I'm sure you can think of all of them at some point, and you'll still be missing another 12. But that's the way the cloud works, right? We have limitless options. Now, the question I ask myself is, given all these options, and even more beyond that, what are good options? How do I choose which option I want to use? How do I make the right choice for my customer, for my project? How do I progress with that? How can I classify those options? And the good thing is, I did a PhD thesis in the university, and at some point I founded my own company. So now I'm at a point in my life where I don't have to do all the work. I let others do the work. And one of my favorite go-to places to do work, like find out what works how well, is have a student write a thesis on that. Works really well for me. I know it's a lot of work for me, but still. So what we did, I have a colleague, Tim Heibel, who wasn't able to travel here today because his thesis is due in, I think, next week. And he sends me emails at 4:30 at night because he's working all night. So he's in that stage of his thesis at the moment. So he is doing a thesis to benchmark, to create a set of tools to benchmark different options for working with time series data. And first thing we did, we need to differentiate between ingress, where we want to read incoming data, and egress, where we want to query the data that's stored. And one of the first things that he found out was a very hard limitation for the ingress. And the limitation for the ingress that he found, unfortunately, was his internet connection. So benchmarking ingress and getting enough data to the database to make the database not be able to cope with it is really hard. And since this is only a bachelor thesis, we decided, okay, let's focus on egress. Let's focus on querying the data rather than getting it into the database, because this is a bit too much for one thesis. So, okay, we said, let's focus on getting the data out of the database and not how fast our internet connection is. Okay, and now I'd like to talk to you a bit about how we designed the benchmark, how we want to figure out which database performs how before I have a look at the results together with you. And the results that I'm going to show you later on were sent to me the day before yesterday at 3:30 at night. So this is really fresh stuff, and I've browsed through a bit of the results, and I can show you what we are doing, and but this is not all written down yet. It will be written down in the thesis, and the thesis will be published, and the code for the benchmark and the code for creating all the resources and everything that I'll show you in a moment will be published on GitHub later on, because we decided that this should be open source and should be available to everyone who wants to conduct their own tests. So it will be all available, but currently it's still work in progress until the thesis is completed. Okay. So the idea was to execute different queries. So query ranges where time between A and B, and to execute those queries with certain amounts of data that we retrieve from the table. So it might make a difference whether I retrieve half of the table or just a quarter of it, or 80% of the table might make a difference to the performance of my database due to limited cache or something. The second kind of queries was what I've already talked about, point-in-time queries. We say, okay, give me the value where the time is this, and to aggregate certain values. What we've designed, what we wanted to do is we wanted to execute each of these queries multiple times, clear query caches and everything in between wherever that's possible. That's not so easy with all the options. For example, if you think of Azure Data Explorer, I think you don't have access to the cache. You can like tear down the cluster and restart it, but that takes a long time. But I don't think that there's something like dbcc clear proc cache or something like that. So it might be a bit harder for some solutions for others than for others. And then test that with different amounts of data. So we had a database that contained 100,000 rows of data, 1 million rows of data, and 10 million rows of data. Just so that we see how does the time series database scale when I query more data, when I use more data. So those were the different scenarios that we were going through and that I'll show to you now. Okay, so first, and this is where it gets interesting. I hope the font is big enough for everyone to see. Should I increase, or is it okay? Okay. First thing we did is we have a set of bicep templates to create all the resources. And as I said, all these will be available on GitHub later on once the thesis is completed and he's completed the documentation in a way that I'm happy with. So we'll have so we have bicep templates to create all of these resources. For example, here you have a bicep template to create your Azure Data Explorer, where you have capacities, where you can define zones, where you have your SKUs and everything. Then he created all the resources, documented on how to create them. So documented on how to create them, how to enable, for example, the timescale extensions and stuff like that for Postgres, so that we can repeat this process. Next thing we did, we loaded batch data. We just created batches of data and loaded them into the database. That's not documented in this repository yet. And then we had functions that queried these databases, and I'll just show you the one for SQL database so you have an idea what's happening here. Basically, what you do is you create your connection to the database, and you create a list of how long it took, and then you iterate the queries you want to run, and each query you run as often as needed and get the results. And once you have the results, you stop your timer and you store the time it took to retrieve the data for this query from your database. Okay, and the result of that was here. Come on. The result of that, yes, he's a student, but I still trust him, so let's go with that. The results you can see here. If you look at the results, what you see is, we log the query that was executed. We log what kind of query it is. Do we want to receive a single point of data, or do we want to receive an interval or an aggregate? Then we logged the minimum, maximum, median, mean of the execution times for that query, and standard deviation, what database scaling it was executed on, and how many rows were in my database at that time, and how often I ran this query. So here you can see we ran this single point query 5 times on a database with 10 million rows. Okay? So basically this is what we did as a benchmark for some of the options. And now what I'll do is, I know it's bad practice to do demos live and type while you're talking and stuff, but I'll still do it because I'm a bit insane in trying to attempt such endeavors. So let's do this. I must admit, I'm not very good at creating Power BI reports. The things I do never look really nice, but they'll serve the purpose right now. Okay, so don't expect any beauty here, but rather, well, I'm on stage, so you wouldn't expect that anyway. But let's rather get some data, and as you saw, the data is in a JSON file. And we'll start with the SQL database. And hopefully that works. If not, I have prepared a Power BI file already where I've loaded all that data. But I'm still in time, so I can show that now. So we've queried, we've ran different queries, and we'll have a look at what we can see there now. So I like line charts. I'm a mathematician, I can't help it. So I want something like maximum, mean, and minimum, and we want the number of rows in the database. Okay, so this is something that you would probably expect, that as the number of rows in your database increases, your execution time increases. Yeah, not very surprising. But then what we can do is we can also break that up by different query types. Okay, so this is the results we see for a SQL database, and here you see this is an aggregate query. This is a single point retrieval. This is range retrievals of 10% and 20% of the data. So basically this is what it looks like if we have a SQL database that was not tuned, that is just as is, and we just dumped the data in a table and then queried the data from that table. So this is just as is performance of our SQL database. Well, I was not very surprised at that, but this, let's set a baseline here for this is what this will look like. Okay, and now let's get some more data and have a look at some of the other results. Any wishes what you would like to see? I have for you ADX, Cosmos DB, Postgres with timescale. Any preferences? ADX? Timescale. I'd like to do timescale first and then ADX, okay? We'll see both, but let's start with timescale. So timescale, as you remember, the Postgres database with the extension built for querying time series data, okay? So let's have a look at that as well. And you can see this is about the quality of Power BI reports I can create. So it's a good thing I'm not doing visuals anywhere. So let's have a look at timescale. We'll just create the same maximum. This is a line chart maximum. Did I choose mean or median? I don't know. Doesn't matter a lot. It'll still, you'll get the idea. Rows in the database are on the axis. And then I want the query type. And this is where it gets interesting. Because now you can see that aggregate queries can take very long, whereas with our specialized indexes that are built for querying time series data, running the typical queries on time series data, they scale pretty well, I would say. So you can see that the comfort of having all of that out of the box, so there was no tuning on the database side involved here. So all the systems are taken off the shelf and just used as is. You can see that there really is an additional value for many users to get really great performances when querying time series data. Now, ADX was demanded, so I would really love to show ADX as well, because ADX was a big surprise for me, the way how this worked. So let's have a look at ADX. It's a good thing that I checked that all yesterday, because there were still some formatting errors in the JSON files. So last night in my hotel room I was editing JSON files because there were commas missing in several places. But that's all that I edited, only commas. So I still feel safe from a scientific standpoint to show these results. So maximum, minimum. Still timescale. Thank you very much. That's because it wasn't appended in the end, but at the top. Maximum. Good that other people take care when I do stuff, because I would have just overlooked that and presented those results. Hey, look, looks very similar. No, we'll do it differently. Okay, rows in the database we want on the axis, and then we want the query type. And already you can see that there is the scaling similar as timescale, that this is a solution that was built for querying time series data and that was built for asking these kinds of queries. You can see that they have a larger gap between, well, I would have to put them in the same diagram for you to see it all. We can do that in a moment as well. Not sure, maybe I'm stretching my luck a little bit, but let's try that as well. But you can see that also ADX has a very, very good performance when it comes to retrieving time series data, when it comes to working with time series data. Now I'm just crazy brave and just adding the timescale in here as well. Okay, this will be the maximum of the timescale there. So you can see that ADX is even orders of magnitude faster than what we see with timescale extension, which is not surprising as it runs on a cluster and is specifically made for these kinds of queries on a cluster, scaling out versus a single database with a timescale extension. Okay, anything else you would like to see here? Because we can play around with the data. I think we have a few more minutes. Yeah, a few more minutes left. So if anyone wants, should we have a look at Cosmos DB? Yeah, okay. Let's have a look at Cosmos DB as well. Just because we can. I haven't looked at Cosmos DB yet, so I'm not sure what to expect there. I looked at ADX, timescale, and SQL. So, and there was an interesting comment made the other day. How it would work to have to run this benchmark against a SQL table with in-memory OLTP enabled and with system versioning for the historic data to tables that are not in memory. And that's something that I would like to try, and I will try at some point in the future. So you see, there's still a lot of stuff that I can really get excited about working with time series data. So okay, let's have a look at Cosmos just because we can. So here's Cosmos, maximum, minimum, rows and database, and query type. And we can see that Cosmos DB, oh, this is interesting, for point queries works really well, but for range queries apparently doesn't scale quite as well as we wanted to. So, well, actually it's not that surprising, because basically if you have a document database, it's good for retrieving a document, and retrieving a series of documents might be challenging for that kind of database. Yeah, so let me jump for the last few minutes. I think I have like a bit over 5 minutes left, right? 6 minutes or so. Okay, so let me jump back into the slides for a second and just wrap this up, and then take any questions or comments that you might have. So I always put the last slide, everything on the last slide for wrap up, because that way, while you look at the takeaways, you maybe also see the QR code and get to evaluate the session. Key takeaway, of course, if you have specialized kind of data with a specialized format that you know beforehand, working with a database that takes into account the shape of the data and the type of the data and the type of queries that you're gonna use against that data will be beneficial. No big surprise here, but still, key takeaway, if you work with time series data, consider using a specialized database, because they bring a lot of comfort for you, a lot of stuff that just works and works well, as we've seen. And it's important that you know these structures, that you recognize these structures, and if you do so, consider the right database. And what the right database is for me, the answer, being a consultant, would probably be it depends. But if I don't want to be a consultant and want to give a real recommendation, my real recommendation would be, I've grown to like timescale extension, even though it's picky with table names and column names. So if you have to start working with time series data, and you want to work in a relational way, you want to work with entity framework, you want to develop an application against that, go with timescale extension, Postgres with timescale extension. And if you don't need the comfort of having entity framework, of having a full tech stack supporting connectivity to your solution, and if you're happy with a bit more experimentation along that, I highly recommend using ADX, because this is a really interesting tool for working with log data, time series data, analyzing data. However, bear in mind that the cost involved in ADX is order of magnitude higher than for Postgres with timescale extension. Since it is a cluster, I think that the cheapest reasonable scaling is something like 600 euros per month, where you would start saying, okay, this is where it makes sense and where it can put its power to real use, where you can actually scale the way it's supposed to scale. Okay, and with that, I've reached the end of what I wanted to show you. I thank you all for not running away when I mentioned that I'm a mathematician. Doesn't happen so often. And I'd be very happy to answer any questions that you have. We have time for discussion, and I see some raised hands here. Yeah, maybe you go first. The benchmark and the SQL Server were without any indexes. Yes, that's right. I'll repeat for those listening, watching online. Have we considered the basic indexing and some most obvious indexing strategies? Yes, we have. However, I didn't want to put too much work on poor Tim because he's really struggling with that bachelor's thesis. So this will happen, but not in the thesis. And these are his thesis results that he provided me with that we're presenting today. But yeah, and of course, I'm aware that if we do that, we'll benefit. Obviously. Would I say that it compares to timescale? I would say that if you know what you're doing and if you're knowing how to index and if you know what queries you expect from your data, you will be able to get it into the same range of timescale. Yes, absolutely. But it will require work on your end. And timescale doesn't require that, apart from nights of cursing over naming conventions. Timescale will not require work on your end. Okay, there was another question. Sorry, I didn't. Are there options to visualize the results of the queries? Yeah, basically we're just writing them in JSON to a storage account at the moment. But since we'll open source the code for that benchmark, feel free to use that and place it. Will it visualize real time? Yeah, we could do that, but at the moment, since we're on the egress side and not on the ingress side, because the ingress side we're always benchmarking our internet connection, which is always too slow to really break a sweat to the Azure infrastructure. So at the moment, we don't have anything like that. We're using a tool set involving Grafana, for example, for IoT projects where we want to have live insights into data. We've also used Power BI streaming for that. We've also used Power BI and auto refresh. So several options depending on what the project requires. Yeah.
More of an observation, I guess. If the bandwidth was an issue on egress or ingress,
Ingress.
wouldn't we've seen it also in egress on the non-aggregated queries?
Okay, if the bandwidth was an issue with ingress, why are we not seeing it on egress with the aggregated queries? Non-aggregate queries. Basically, that's true. That could happen. However, we ran the tests on Azure Web App or Function App. I'm not sure which he chose in the end, so that we didn't have any problem with well, we didn't see any effect here. The effects that we saw would be what I would expect from scaling. So I didn't see if we. Yeah, we didn't see any pressure on the pipe there. That's right. Basically, if I had seen effects that I couldn't explain or that would be unexpected, then I would look into that direction. However, since the results were basically what I expected them to be, we are monitoring the traffic and the limits for the egress. We didn't see it hitting any limits during our tests. So it might be that we hit some, but then they were well hidden in what I expected to see in behavior. Okay, any other questions or comments? If not, then I would like to thank you all for being here. I think I've finished a minute early, if that's not on time. Thank you all for being here. Have a great day.